Everything we see around us is made of matter. Me, you, our planet, our sun, everything. But is that really all there is? Right now we have a model, named the Standard Model, that explains how the universe works and lists the building blocks of our universe. This model, though, fails to explain some of the things that we observe. Back in the 30s, an astronomer named Fritz Zwicky was observing two galaxies orbiting one another. Something though seemed a little bit off. When two objects are orbiting one another, they need an attracting force to keep them together, as well as some velocity so they do not collide. The stronger the force, the higher the velocity must be to keep those two together. In this case, the force is gravity, whereas we know the more mass you have, the stronger the force is. What Fritz saw, on the other hand, was the galaxies spinning around one another in such high velocities that should make them escape the attraction of one another immediately. So, he assumed the force holding the two galaxies together was stronger. The problem was that for a stronger force you need more mass, and he couldn't see any more mass. He named that mysterious thing that he could not see dark matter, because it would not interact with light, therefore he couldn't see it. As it turned out, his measurements were deeply incorrect, but the basic phenomenon was still there. Years later, an astronomer named Vera Rubin would find out the same matter loss while observing how gases orbited around the center of a galaxy. While even later, we would find out that the gravitational pull of galaxies was stronger than expected by their mass, by observing how much light was bent by them. Therefore, to have higher gravitational pull, they should have more mass. The moment scientists started to believe that there was something out there that we could not see, they started making lists of things that this dark matter could be. But one by one, they started crossing all those things off their lists, because they just couldn't be what they saw. For example, dark matter was not brown dwarfs or rogue planets, because those things could reflect some light. And it was not cold gases, because cold gases would emit some kind of radiation. In the end, anything that was made out of normal byronic matter was just not it. There are still many theories of what dark matter could be. Most of them talk about strange hypothetical particles outside the Standard Model. Most popular amongst them are the theory of axions, which says that dark matter is made out of a new particle called an axion that is predicted to have the properties that we see in dark matter, and the theory of supersymmetry that says that every particle has a similar associated superpartner and that dark matter consists of some of those superparticles. But neither of those has been proven yet, so in reality we do not know. Detecting and studying dark matter is not an easy task, since it doesn't interact with light, and for all we know matter. But we are still trying, and we hope that one day we will find the answer to one of the biggest questions of modern science.